Formal charge is the charge a bonded atom would have if all the atoms had the same electronegativity. To find it, you must first draw the Lewis structure. I can't emphasize how important it is to be able to draw a correct Lewis structure, not only for finding formal charge, as we're going to do here, but also for determining the geometry of molecules. You have to be able to draw a correct Lewis structure, so spend lots of time practicing that. Here's how you find the formal charge on an atom. You take the number of valence electrons in that isolated atom, and we find that number just by looking at the periodic table and deciding how many valence electrons an atom has. And then we subtract off the number of electrons that are assigned to the atom in our Lewis structure. The number of assigned electrons is, as I've written down here in the lower right, it's all of the unshared electrons that are on that atom and half of the bonding electrons. We'll illustrate this on the next slide. When several Lewis structures are possible, the most stable one is the one in which, first, the atoms have the smallest formal charges, and second, the negative charges reside on the most electronegative atoms. So let's find the formal charge on each atom in the following species. This ion is called the sulfite ion. The first thing we need to do in finding formal charge is to write a Lewis structure. Let's do that. To find a Lewis structure, we need to count up valence electrons. Both sulfur and oxygen have 6 valence electrons, so 3 times 6 is 18, plus another 6, that's 24, plus 2 more for the charge here, that's 26. We're going to put the sulfur atom in the middle, put the oxygens around the outside, complete the octets. If we count up those electrons, that's 24. The extra 2 need to go on the central atom, which is just perfect because now sulfur also has an octet. We're nearly done, but not quite. Since this is an ion, we're supposed to put square brackets around it and show the charge in the upper right. Now we're ready to find formal charge. To find formal charge, we first write down the number of valence electrons that each atom has. And we already said from the periodic table that sulfur and oxygen both have 6 valence electrons. Now we need to look at our Lewis structure and count up the number of electrons that are assigned to each of those atoms in the Lewis structure. And the rule is that unshared electrons are dedicated solely to one atom, and bonds, one electron goes with this atom, one electron goes with the other. So for sulfur, you can see we've got 2 electrons that are assigned, plus one of these 2, one of those 2, one of those 2. That's a total of 5. Oxygen, very similar. Oxygen atoms have 1, 2, 3, 4, 5, 6, and one of these, that's a total of 7. So then you go 6 minus 5 is positive 1, and 6 minus 7 is negative 1. So the formal charge is as shown in the middle of the screen. Formal charge is most useful when trying to decide between Lewis structures that seem to be equally correct. If we count up the valence electrons in this ion, nitrogen has 5, carbon has 4, so that's 9, sulfur has 6, so that's 15, plus 1, so we have 16. With a little experimentation, we could draw several apparently equally good Lewis structures. I won't go through that right now, but if you took a little time, I'm sure you could convince yourself that on the face of it, it seems that these 3 Lewis structures could all work. They all have 16 electrons. In each of them, everybody's got an octet. Is there one of these that's better than the other? And this is where formal charge comes in kind of handy. So let's find the formal charge on each of these atoms. Nitrogen has 5 valence electrons. Carbon, of course, has 4. Sulfur has 6. So I'm going to write that down for the other 2 Lewis structures. Now let's count up the assigned electrons that we see in each Lewis structure. And for this nitrogen, On the left, you can see that we have 2, 4, 6, 7 electrons assigned to it. For the carbon, one of those, one of those, one of those, one of those. That's 4. And for sulfur, you can count up 5 electrons that are assigned. These two, and plus 1, plus 1, plus 1, that's 5. So do a little subtracting, and there are the formal charges on the atoms for this Lewis structure. Well, let's do that for the rest here. For the middle Lewis structure, the nitrogen has 1, 2, 3, 4, 5, 6 electrons assigned to it. The carbon has 4, and the sulfur has 6. If we do some subtracting there, we get that. 5 minus 6 is -1, and a 0 and a 0. Right away, we can eliminate the Lewis structure on the left, and that's because the preferred Lewis structure is going to be the one that first has the lowest formal charges. And here we have a 2 and a 0 and a 1, and in the middle we have a 1 and a 0 and a 0. Clearly, the one on the left with the larger formal charges, that one can't be right. So now we have to choose between the other two Lewis structures. Let's count up assigned electrons for the right Lewis structure. For nitrogen, it's going to be 5. For carbon, it's going to be 4. And sulfur, I'm seeing 7. Let's do some subtracting. These have the same numbers, a 1 and a 0 and a 0 for each. The next rule is that the most negative formal charges should reside on the more electronegative atoms. So in the middle Lewis structure, we have a negative formal charge on a nitrogen, and in the right Lewis structure, we have a negative formal charge on the sulfur. Who's more electronegative? Nitrogen.